Okay, so then we've got, that's just the pump, okay? So then we've got to take into account the efficiency of the thing that's driving the pump, okay? Since those things aren't 100% efficient. So we've got all of our system losses down the system. Then the pump is maybe at best 60%, 65% efficient. Then we've got the efficiency of the driver, okay? So the driver is usually an electric motor, okay? And so about the only thing that we can go by from these motors is what's on the nameplate. And sometimes there's not even a nameplate, okay? So at that point, you kind of just, you can see what the demand is and estimate the size of the motor, but that's about as far as you can go. You can talk to the farmer. A lot of these guys keep really good records, is my experience. And I mean, these guys get out a file and they got like everything that they ever did to this motor, But how many times has it been rewound? Okay, you can rebuild these motors. And so what they do is if the motor fails, then they take the motor and they bake all of the wire out of it, and then they string new wire in it, rewind the motor, and if they do a good job, it's much the same efficiency as it was before. If they do a crappy job, then it's less efficient, okay? I have actually heard recently that some motor rewinds, the efficiency's improved. Is it the right motor? Okay, this is what we're talking about. This is what I did here was, the thing is the frame size. Do you guys know about frame size of motors? If the frame size is a number that's made by all the dimensions of the physical motor, the mounting of the motor, how big the shaft is, how long the shaft is, all this stuff about the motor goes into the frame number. Okay, so the frame number is there. Well, that's the same physical size of motor, but you can get different horsepowers at the same physical size of motor. And so you can get a motor, say the motor that was on the system to begin with was a 100 horsepower motor, and the guy didn't have a 100 horsepower motor. He says, well, I got a 125 horsepower motor, I'll sell it to you for the same price, okay? So the farmer says, God, I gotta get this thing going, gets the 125 horsepower motor, it goes right in, it's the same size, same physical size, but now you've got a motor that's running at part load, okay, and motors that run at part load are less efficient than motors that run at full load, okay. So and this is the example is here, the frame size 404T, okay, whatever that means. Here's this combination of these different dimensions, 404T. They're all the same speed. This happens to be 1200, not a common speed, but I'm just trying to make an illustration. 404T, you can get a 50 horse, a 60 horse, or a 75 horse motor. That's, 50% difference. So you have to, if you do all these losses and calculate, this is what my field requirement is, and this is the pressure requirement. Geez, I should only need a 50 horsepower motor. This is a 75 horsepower motor. And then that's going to be a very cost-effective energy conservation measure to put in a smaller motor.
We had a frame size on this one. We took a picture of it too.
Yeah, and the frame size is on, and that's what they'll do, is they'll say, oh, well, I just need a motor that has this frame size.
Well, we can look at this later, but we took a picture of the two nameplates, or two of them there this morning. Okay. And then the electric motor there, one of those does say frame size. If you and I can email these photos if everybody wants a copy of this.
Now oh wow, yeah. these are other energy audit pictures.
Is there a moisture problem there?
Maybe a little, this is actually termite damage.
Oh.
Okay, where are we at? Oh, engines. Engines are really hard because you don't know how efficient this thing is, okay? And there's not, you will have, in the specification, you will have, find something called brake-specific fuel consumption. And this is how much fuel this engine is going to use at a certain power output. You know, the thing is a lot of these engines have been out there for 20 years and they're worn out. I mean, they're not worn out, but they're worn, okay? And so they're not going to be that good. You can go from the specification, you can go from the sales brochures if they're fairly new, but these engines are almost always somewhere between 20 and 30% efficient. 30% is pretty good, okay? You can, some of these really nice big ones might be 32, but 20 to 30% is pretty good. So this is the kicker on these engines, and these guys that they have this engine and they say, well, it's running fine, I don't want to change it. But if they're close to a power line, they're crazy to not connect to the utility, okay? The electric motor is about 85 to 95% efficient, and some energy efficient motors are better than that, 96 and a half. So the cost for the power going into the pump is about almost 6.5 cents or 6.7 cents a kilowatt hour. Engines, 20 to 30%, and I picked 25% efficient, right in the middle of that. The cost of the per kilowatt hour going into this pump, 42 cents, 39 cents, 45 cents. So it's like, five or six times as much money to run an engine just for the fuel. And that doesn't take into account the maintenance costs, the tune-ups, oil changes, maintenance, that kind of stuff. So, but the downside is the fuel switching is really expensive because the power line extension costs are high. So the number I always carried around with me when I was in the utility was $25,000 a mile for 3-phase, but I think it's probably more than that now. It could be $35,000 or $40,000 a mile. So if the electric is right there, if the power line is right there, and they just have to put in a drop, lose that engine. That's the case of this half-mile pivot I'm working on. The engine is right there and there's a power line right there. About the first thing I'm going to say is lose the engine, okay, and switch it to electricity. It will save energy because the utility system is probably more efficient than the engine to get the energy there.
I have a guy who's a prime target for this program. He's using 10,000 gallons of fuel a year to grow hay.
Yeah. Oh, it's crazy.
And he's making money.
I don't know if he's making money.
Yeah. So, okay.
Been around a long time now.
Yeah, so about all you can do on these motors, all the information about the motor should be on the nameplate. This one happens to be, remember it's 50 horsepower. Now, if you go through all these calculations and you come up with this motor should be, the system is, it appears to be working just perfectly, but it's using more than the horsepower of the motor, okay? You might be okay, because these electric motors generally have something called a service factor, okay? And a service factor, and people think that you might be able to run the motor at this overload for short periods of time. No, you can run the motor at this overload all the time, okay? And so you might find that your power consumption is bigger than 50 horsepower, but as long as it's less than 50 times 1.15, if I had a calculator, I could calculate that, but you're 57 and a half. Oh, yeah. You see, if I wasn't standing in front of people, I could probably do that. But I used to tell people I don't do math in front of people. So I can mess them up. Okay, power factor. Power factor shows up on the nameplate. This one happens to be 85 and a half. What the power factor is, and this is where I'm glad I'm a mechanical engineer, because electrical engineers are really bizarre. They use math like that they admit is unreal. Okay, and so but the bottom line is the utility has to serve the motor with power, and it also has to serve the motor with energizing magnetism. Okay, and so when the utility is delivering this energizing magnetism, it shows up to the utility, okay, as a loss, but to the motor, it doesn't see it. Where it comes into play is in the utility programs, we have to derate everything by the power factor for the utility. Low power factor indicates less efficient equipment, okay? And so if the power factor is low, sometimes we have to add capacitors to bring the power factor up, because the thing that causes low power factor is something that's got a lot of wire, okay? It's an inductive load, and motors are all wire, okay? So you'll have a big inductive load there, have a low power factor. Sometimes we can correct it with capacitors, but we would generally let the utility do that. And this is something that's fairly recent that the utility's been doing, but it's pretty serious, and it's weird because electricians can't measure power factor, or don't generally have the tools to measure power factor. It's just the energy freaks that will measure the power factor, but it is important. Okay, the only thing about one phase and three phase is much more efficient, okay? So if you have a three-phase motor, it's going to be much smaller for the same horsepower than a single-phase motor, okay? And so in any instance that you can, if the farmer has three-phase power there, but the motor is a single-phase motor, you're going to want to encourage them to change that to a three-phase motor. It's going to take some modifications to the mounting, because the three-phase motor is going to be quite a bit smaller.
So I don't see the power factor on this. Is that unusual on the nameplate of the one we took?
It's not unusual, yeah. In fact, I was kind of surprised that this one had the power factor on it. Okay. Yeah, but when you're calculating the efficiency of the motor, you say it's 37 and a half kilowatts times the efficiency, 95%, times the power factor. Mm-hmm. That's actually what you're getting out of the motor. Mm-hmm.
So you could probably go online and look up more with your serial number and your model number, and maybe get a better product description.
Yeah, you might be able to. The thing is the power factor is going to change over time also as the motor ages, because it's an indication of there probably insulation breakdown in the motor, and it's all electrical stuff.
Find that information.
Well, if you really need to know the power factor or something, give me a call. I'll come and measure it.
Because I won't.
Yeah. It hasn't.
Give me a call.
It hasn't happened yet.
$1
Yeah. Give me a call. Give me a call. Yeah, bring your power factor meter.
That's what I offered.
Okay.